The next step in bivariate analysis is linear regression. So we've already shown graphically from using correlation analysis that there is some relationship between two variables, and now we can compute and define that relationship more precisely. So when the scatter chart and the correlation coefficient show a relationship between the two variables, try to find a linear equation that describes this relationship or relation. But before we do the actual computation, let's show how linear regression works with a little rough exercise. We're going to guesstimate a value of y from x using our chart without any computations. So this is the chart we already drew by hand. You can see it's joining the bottom left-hand corner to the top right. That's our estimate of the line of relationship between the two variables. And we pick a line which joins points. So I just picked the top point, the top right point and the bottom left point, and it seems to be a reasonably good fit. And from that line, we can now make predictions about values of y from x. So let's take an example. We know, let's take examples here. We'll just get the pointer up. We know, for instance, for this point here at the top right corner, the value of y and x that match. And we know for this point, what are the values of y and x. But now, because we've got a line of fit between the two variables, we can now make estimates for other points that don't actually exist in the chart. So for instance, let's take the value of x of 120. Someone has a salary of 120. They're around here in the x-axis. If we draw a line up here, it comes up to about here on the line. And then from that line, we can go across horizontally to this point on the y-axis. So we can say that for a value x of salary of 120,000, the value y of car should be around 61,000. So now we've got a fairly good relationship description between the two variables. So let's now do a computation for that. So in the last task, we did a computation just by eyeballing the chart. Now we can do a computation. So this is a straight line, and the formula for a straight line is y equals a plus bx. So x is the initial variable, salary, and y is the response variable, car value. Okay, a is the intercept on the y-axis. So the point at which the orange dashed line meets the y-axis is a, and b is the slope of the line. So it's the standard formula for a straight line. So we can see here, now I picked 2 points from our table in our original data set. So you can go back and see those points. So the slope of the line is the increase in the y-axis over the increase in the x-axis for any 2 points. It doesn't particularly matter which 2 points, but just for simplicity, I picked 2 points from the table. So for those two subjects on the data set, 107 is the car value and the matching salary is 217. And then another subject line is a car value of 19 and the matching salary 43. So you can see the first pair is the top right corner and the second pair is the bottom left. And when you deduct the y increase over the x increase, you get a slope of 0.5, and that's what you'd expect to see. So because a slope of 1 means an exact 1-for-1 match. Every increase in salary of €1 gives you a car value increase of €1. Whereas we can see here from the scales, salary goes up to around 250, car goes up to about around 120. Approximately every extra dollar or euro at salary gives you a 50% of 0.5 of a dollar or euro increase in car value. So it's 0.5 of a slope. So that's we've got y, we've got x, and we've got b. So then we can calculate a then, and a is equal to 5. Okay. So we just read off a. We can read a off from the chart. In fact. So now we've got a formula for any value, and we can compute exactly what any y is for any given x. So taking the same value again, if we feed into our formula x value of 120, we get an actual y value of 65. So what we were doing was we were doing a rough estimate and getting 61, and the formula gives us a value of 65. So that's the correct car value for a given salary of 120. So here we're going to run the actual computations for the regression line. And here are the formulas. The regression formula is the straight formula for a straight line y equals a plus bx. The slope of the trend line can be calculated using the following formula for b, and you can calculate the intercept a as follows. But we're not going to do that manually in Excel. We're just going to use tools in Excel and SPSS. So for instance, in Excel, we again go back to our old friend data analysis menu. We pull out the data analysis dialog, and instead of the tools we picked before, we pick regression. We run the regression tool. It'll ask us to highlight the cells with the data that we want to do the regression for. We do that, and we select an output for cell, and the output will look something like this. So you get summary output, regression statistics, ANOVA, and the coefficients. So let's take a look at what those actually look like. Here we have the summary output on its own, and we want to look at that specifically. So the first thing we want to do, we're interested in, is the R-square. So the R-square is the coefficient of determination. Now you can see the number above that is multiple R. That's actually the same as the correlation coefficient. So we already had that in correlation coefficient, and the multiple R in regression is the same. But when we square that, so 0.96907 by 0.96907 gives us the coefficient of determination, which is 0.939. And this is an exact measure of how related the two variables are. So what it's saying is that 94% approximately of the change in y is caused by x. So that's a very strong relationship, that x causes almost all the change in y. 93.939 or 94%. But we're not going to look at the standard error and observations, and we're not going to look at ANOVA, but we're going to go down to the bottom to see the coefficients, because these are the values for the regression formula. So you can see the intercept there is 8. So we want to plug in the values for A and B, and they're written out here. So you can see that A is the intercept is 822, or should be 823 rounded up really. Now that's 823 absolute. Now I estimated from the chart that the intercept was 5,000. It's actually less than 1,000, so that's the correct value there. And you can see below that the other coefficient is the x coefficient. The slope is 0.52. There it is there. And that, we estimated that from our chart at 0.5, so our estimate wasn't too bad. So now we've got exact coefficients for our formula, and for any x we can compute a y. So going back to our previous example, for an x value of 120,000 salary, the y value of a car should be 63,000, which is slightly different from our rough computation, and that's the correct answer using a regression formula. So in conclusion for this week, we've completed univariate analysis. We've looked at bivariate analysis extensively, scatter charts, correlation analysis, and regression analysis. And we've one thing left to do in bivariate analysis. We want to look at bivariate analysis for non-continuous data. So we'll look at that after the midterm test.